see. Okay, so I believe all set. Let me share my screen. Just give me one more minute. Okay. Let me know if you guys are able to see my screen.
Yes, visible.
Okay. All right. So we have done discussion about the basic concept and the device level understanding about the controller, edge devices, and each of the devices functionality we understand in the previous sessions. And also we discussed the type of tunnels, right? Means basic concept of tunnels, how the tunnel is going to be created. So we'll try to do more understanding on that tunnel. Who joined with the name of K? May I know your name, please, if you don't mind? Would be great. Someone joined with the name of K only. May I know your name, please? So I can rename it. Okay. So I'll wait for your name. So we have done discussion about a lot of things, right? And also we try to try to understand like what are the different use case of the tunnels, right? So we'll try to explore more about the tunnels, right? I give the basic idea about we have the TLS tunnel, we have the DTLS tunnel, we have the some BFD tunnel, IPsec tunnel, and also we have done discussion about control plane and data plane, right? So let me put some more information on that. And also we have to understand about the underlay connectivity versus overlay connectivity. So also we little bit haven't done discussion about that, right? What is the underlay, what is overlay? But let me just quickly go through that all concept and then we'll see how the tunnel is going to build and how the routing decision is going to be happen in the SD-WAN fabric. Okay. So if I just discuss about the underlay versus overlay. So anyone can explain what is a underlay and what is overlay? Underlay
Uh,
versus, yeah.
Underlay is something like a static route or a B or an IGP or a BGP, and an overlay is a tunnel which runs on top of it.
IGP, BGP, and overlay on top of that. Okay. Anything else? Anyone else want to define underlay versus overlay? Any other definitions we have for the underlay versus overlay? All right. So thanks, Muthu. So let me define what is underlay.
Yeah,
So
sir, for virtual connection, we can consider it's overlay, and for underlay, it means physical connection.
virtual connection, right, is the overlay, right?
Yeah,
And physical connection.
we can consider it's underlay.
Okay. Underlay. Okay. Thanks, Ajit. All right. So, yeah, Manjit, you want to say something? Okay. So, what is underlay? Underlay, just you can think about, if I just want to define in one line, basic IPv4 or IPv6 reachability is known as the underlay. Means if you want to reach from one place to another place, that could be via the IPv4 or IPv6, that is always going to consider as the underlay, right? And this can be done via the static route, right? This can be done via the BGP, might be the MPLS, right? There is a contradictory, might be the MPLS. L3 VPN is going to act as the overlay, right? But let's just think about the BGP, MPBGP like acting as an underlay. Or IGP is not technically correct because for the WAN connectivity we never use the IGP. It is not recommended because they have the very high processing and they have to exchange a lot of messages. So if you're going to run the AIGRP and OSPF, so they are going to utilize the entire CPU of the routers. So that is not recommended. So most of the case we are going to use the BGP or the static route. So just make the IPv4 reachability or IPv6 reachability from point A to point B. So that is always going to be underlay. So what does means basic IP reachability means if you want to build some sort of the tunnels, right? Like what is tunnel? IPsec tunnel, right? You want to build the GRE tunnel. Any tunnel, like if you want to build the DMBPN, that is going to again use the your GRE IPsec concept. If you want to build the any VXLAN tunnel, if you want to build the DTLS tunnel, you want to build the TLS tunnel, you want to build the OMP, right, routing protocols. So these all are going to act as the overlay. But if you want to build these kind of the tunnels, you always going to require the underlay connectivity. If there is no underlay connectivity, you cannot form the any overlay connectivity. Let's say one of the example is IPsec. So if you want to build the IPsec tunnel, so you have to make sure if you want to build the IPsec tunnel from this device to this device, right? Just take an example. So whatever the public IP address available here, and what is the public IP address associated here, this must be reachable. Means via the static route or might be the BGP. Any of the routing protocol is going to be there, but they must be reachable. If there is no basic reachability, you cannot form the overlay tunnel or overlay connectivity, that is IPsec. So the underlay in one liner, this just a basic IPv4 or IPv6 reachability is always going to known as the underlay. In top of that, if you want to build the connectivity, that is known as the overlay, like the IPsec, GRE, OMP, TLS, DTLS, and all. So this is going to be considered as the overlay. So in our scenario, what is going to be happen? We have to build a lot of tunnels, right? We have to build the IPsec tunnel. We have to build the BFD tunnel, right? We have to build the TLS. We have to build the DTLS, right? We have to build the OMP routing protocols. These all is going to build. And without this, you are not going to make the SD-WAN fabric operationals. So as I mentioned in the previous sessions, if you want to run the IPsec or BFD, this is going to only run between the VS devices or between the CS devices or between the VH or CH. Means if you have the VH to VH, this is going to be formed. If you have the VH to CH, then it is going to form this IPsec and BFD, right? Clear? TLS and DTLS, right? We discussed TLS and DTLS. TLS is always going to stand for the TCP based tunnel. DTLS is UDP based tunnel. TCP is going to be slower because it's reliable, like they have to do the three-way handshake. And in this UDP, it's faster because they don't have to do any like three-way handshake. And it is just going to create the tunnel, right? So unreliable connection, but it's going to be very fast. So this TCP UDP based tunnel you can create. We'll see how it is going to be created. But yes, this is going to be create the control connections. So this is known as the control connections. And which all devices is going to get these control connections? So this control connection can be created by the between the VH to you can just vSmart, vManage, and vBond. This is the one combination. Means VH can go with the vSmart, vManage, and vBond, right? Now the next set of the connection between the vSmart to vManage and vBond, right? vManage to vSmart and vBond. vBond to vSmart and your vManage, right? These all combination is going to be created. So every device is going to create the control connection with each other, and also the VH is going to create the control connection with the vSmart, vBond, and the vManage. Now this is a TLS and DTLS. If we talk about the OMP, as we discussed in the last session, this can be created only between the VH to vSmart, and the second option is a vSmart to vSmart. This is the only combination we have. None of the other devices is going to create the OMP tunnel. Means this is a pure routing, and this pure routing is going to happen between this vSmart to VH, VH to vSmart, and if we have another vSmart, then it is also going to be created. Okay. So this is the all tunnel. We have to learn how it is going to be created, right? Apart from that, we have the certain other concept, right? We have the concept in the SD-WAN which is known as the VPNs, right? Similar to the VRF, right? So in this SD-WAN, these VPNs are going to exactly work as a VRF. Means if I'm going to create the VPN in this particular router, this is going to give the separate routing engine, right? Means if my VPN is 1, then this routing instance is completely different if I have the another VPN 2, similar to the VRF, right? So in the SD-WAN fabric, we have the range of the VPNs that start with the 0 to 65527. This is the range, right? VPN range. In this VPN range, some VPN are reserved, like VPN 0 is reserved, VPN 512 is reserved for the special purpose. Rest we have the VPN 12511 and VPN 513 to 65527. So these are the different VPN range. So what is this is VPN? This is VPN 0 is always known as the transport VPN, right? This VPN 512 is known as the management VPN. And this VPN 512 means 1 to 511 and 513 to 65527 is known as the service VPN. So let's understand what is my management VPN, what is my service VPN, and what is my transport VPN, right? So this transport VPN always going, if I want to configure any WAN circuits, right? If I want to configure any WAN circuit, let's suppose these are two transport. One is the internet, one is the MPLS. So if I want to configure anything for this WAN circuit, it always going to be configured under the VPN 0. Means they are basically going to represent your WAN. Okay, clear? Similarly, if I want to configure anything related to management, right? If I want to do like device management, like similar to loopback address. So it is always going to be configured under the VPN 512. It is not necessary. Even we can use the service VPN for the management purpose, but yes, there is dedicated VPN available. If you use, that is the best practice, and that is going to accessible and routable, and you can access through that remotely if you want to access that particular box. That is a VPN 512. Now we have the service VPN. Service VPN is something where you have to integrate your LANs. Means if you have your LAN connection, that every LAN connection is going to under the service VPN. So we'll see how it is going to be configured, right? So these are the brief things, but I'll show you how these are all going to be configured. But most important thing you have to remember, if you have to do any configuration related to WAN, this is going to under always VPN 0. If you want to do anything related to LAN, it is going to VPN 12511 and VPN 513 to 65527. And anything management, you just have to remember 512 VPN. Okay. So this is all about the VPN, all about the tunnels. Now let's start doing the configuration about the lab. Okay. So as we discussed, right, in the SD-WAN fabric, we have the concept that zero trust fabric. We discuss about that. What is zero trust fabric? Means you're not going to trust on anyone, right? Even someone is belong to your family, and he's going to ask something to share your password or something else. You are not going to trust them. You are not going to share that because they might be misuse that. So you always going to use your password, your email, or whatever like related to the secret thing by your own, so that nobody is going to misuse your informations. Similarly, in the SD-WAN, if I want to join my fabric, I have to follow the zero trust fabric model. Like I'm not going to allow, means the control plane devices are not going to allow anyone randomly join the fabric unless or until they prove their identity. And what is the combination of the identity proof? That is the chassis number and the serial number, right? There are two things is going to be required. And if that chassis number and serial number is going to match in the VBond database, that is your ZTP server or PNP server, then only it is going to allow to join the fabric. And then it is going to communicate to other branch location. So to achieve this zero trust fabric, we have to build our controller, right? So these are our controllers, right? And in this controller, we have the three devices. That is a vManage. We discuss what is the role of the vManage. We have the vBond. That also we discuss what is the role of the vBond. And we discuss about the vSmart. That also we know that what is the vSmart. Additionally, we have the another device that is a root CA. So we'll discuss what is the root CA and what is the use of the root CA. So let's discuss about the root CA a little bit. Then we'll discuss about the controller. Okay, just give me 1 minute. So just give me 1 minute. This you all discuss. So I was talking about zero trust fabric, right? So in this zero trust fabric, what is going to happen? My devices are not going to by default trust, means one device to another device, unless they are going to prove their identity. So in SD-WAN, what is going to happen? Let's suppose you have taken solution from the Cisco, right? And in this Cisco solutions, you are going to purchase the devices from the Cisco, like Viptela box, or might be the, which is known as the nowadays known as the managed devices. Could be the VS1000, 5000, or might be the 2000. So each of the box which is you are going to purchase from the Viptela, they have their chassis number, you can see, and also they have their like serial number. So you can see here these two information. So chassis number and the serial number. So based on this chassis number and serial number, they are going to be like validated by the your control plane devices. So who is the actual device who is going to validate? That is your vBond, right? So what is going to happen during the manufacturing process? What is going to be happen during the manufacturing process? One of the TPM like module is going to be installed in each of the devices. That is known as the tamper-proof module. And this module is going to be installed during the manufacturing process. And in this module, there are a certificate, means serial number is always going to come with the box because the vendor is going to create the serial number as an inventory for the each of the devices. But certificate uniquely going to install in the tamper-proof module. And this certificate is going to be signed by the root CA. This could be the EVNet root CA, right? This is the one way. Certificate is signed by the EVNet root CA. And this root CA is always going to trusted by the control plane element. Means if I have the vSmart, we have the vManage, and we have the vBond, they are going to trust that certificate because they know about that. This is signed by the EVNet. So they are well aware about that particular certification part. And they are going to just onboard you if you are going to come with that certificate, and the certificate is going to be validated by these devices, right? And another thing, semantic root CHN of the trust is used to validate control plane. Means in the same device, means the root CA, one is the EVNet root CA is going to be used, and this is going to validate by the your control plane devices. But if I want to validate revalidate, means we have to check the cross validation. Means one means my device is going to validate by the control plane. Similarly, control plane also need to validate by me. So you can see semantic root CHN of trust is used to validate control plane elements. Means any control devices are going to come to me. I'm also going to validate whether their certificate is valid or not. So this is a special semantic root CA is going to be there, and that is going to be validated. This completely going to be automated process, right? Means if you're going to take in the Cisco solutions where you have the entire PNP portal, ZTP portal, you are going to deploy the controller in their environment, then it is going to be happen. But let's suppose you don't want to use these all things and you want to use your own alternate enterprise root CA. Means we have the serial number, like chassis number of the device, right? But certificate you want to generate, and you want to make sure whatever certificate I'm putting on the data plane devices, means the VH or CH, same certificate should be means same certificate should be available on the control plane devices, and both are going to be validate to each other with the help of the root CA, means which is my certificate signing authority, right? So that's why we have the alternative that is used as a root CA, that is known as the enterprise root CA. So this is going to trust and use to validate the control plane element, and also it is going to help to validate data plane element, which is not written here, but yes, definitely the same like enterprise root CA is going to validate both of the devices, means control plane and data plane. And it can be also installed automatically during the JTP process if you have the integration with the your already like enterprise root CA automated way, then it is going to be happen. I'll show you how it is going to happen. But if you want to do the manually, then it's also possible. So in our case, we'll do the manually because we don't have the Cisco contract and everything. So we'll do each and everything manually. So we'll see how the validation is going to be happen. So if I little bit discuss about more about the root CA, what is the root CA and how it is going to work. So just think about the passport office, right? So in passport office, what is going to happen? We have the certain things, right? First, let's suppose you want to apply the passport. So what do you have to do that? First, you have to go online and fill the form, right? After filling the form, you have to book the appointment, right? After appointment, what is going to happen? You have to visit the branch, right? Passport office, what is it is the branch passport office we have. Then we have to visit the branch. They will validate your online appointment plus your physical documentation, right? So after validation plus your biometric, everything they are going to validate. After doing these validations, they will take your all data and they will do the background verification, even the police verification. And after finally everything is going to happen, then your certificate, means your final passport is going to be granted. So your passport is going to be there. So you see how many steps are going to be there. It means first time you are filling your form, online data. Based on that data, you have the appointment. Then you are going to again the branch. Then branch is going to validate your all the credentials. Then they will do the another level of verification. Then they are going to do the your final passport, means they are going to issue the final passport. Same thing is going to happen with this entire process. Means this is acting as a root CA is the passport office who have the authority to issue the certificate. Means they have the like authority to issue the passport. So, but before issue the passport, what you have to do that? Let's suppose this device want the passport. So first, they have to take the appointment. Means they have to put some information in their like online form. Based on that, they are going to get an appointment, and he will give the form details. So this device will have the like some like information available from the root CA, and based on that, he will put some detail. Now he have the detail and some kind of data. Now what is going to be used? He will use some his local property, and based on that he will request that can you validate my all detail and give me the final certificate. Then this root CA is going to validate again your all the credentials, that is known as the CSR, certificate signing request. And based on their CSR request, it is going to validate whatever data you have shared to me during the online filling the forms and whatever the device property. Based on that, they will validate their own all data. And if everything is going to, let's suppose symmetric or symmetric key is going to match, then they will generate the final certificate, and then you are going to install in this particular device, and then you are going to be live. So the same thing we have to do that, and all certificate process is going to be happen. So we'll understand how this step by step CSR processing is going to be happen, certificate is going to be issued. Before that, if I want to start this configuration, control plane configuration, then how the step-by-step configuration is going to be happen. So in this lab, we have the management PC. You can see this is my window management PC. Why this PC is going to be important? Because by using this PC, I will take access, GUI access of this vManage. Without vManage GUI access, I cannot do the configuration of the entire fabric, right? So I have to do some configuration. By doing some configuration, I will able to log into this vManage. So one connection, you can see this is like we have this particular IP address configured here. So this is my IP address 192.168.10.0. In this IP address, you can see I'm going to use .10 here and .1 here from this subnet range 192.168. So they are going to become the same broadcast domain. So probably I will able to ping from this PC to this vManage. So once I'm able to ping, I can go in the browser and I will do the HTTPS and I will take the GUI access of the device. Okay. So this is the one set of the connection where from this PC I'll take the GUI access. Another set of the connection, if I want to take the real internet, then I have the dual NIC here. Based on that NIC, I will go to the internet. I can just access the Google or maybe the YouTube or Gmail, WhatsApp, whatever I want. Because it is going to be required here in this lab setup. So that's why I just use this particular internet connection as well. So let me show you how it is going to be look like. Any question, guys? Anyone till now? Or all good? Me. So when you on this PC is going to ask the password. Okay. So you have to note down the password. Password for this PC is 123. Okay. So you just have
Sir,
to.
one doubt, sir.
Yes.
What are the devices you use, sir, for edge and for the edge routers and for the cloud?
So these are the actual VS devices, right? These are the actual VS devices, but it is known as the VS Cloud, right? It's not the VS 1000, 2000, or 5000. These are the physical devices. So we are using the virtual images. So they are going to, means it is going to work exactly the same way, whether the 1000, 5000, 200 going to work, but they are the cloud devices. Similarly,
But sir,
CS device.
with ISR, CSR, or
No. Let me. So see, we have in SD-WAN, we have the two type of devices. One is the Viptela devices, right? This Viptela come as a physical and also virtual. Physical is VS 1000, 2000, and 5000. They are different model, right? Virtual is only VH cloud. Okay. Now we have the Cisco Edge, Cisco devices, Cisco SD-WAN devices. In this we have like CSR, we have the ISR, and we have the ASR. These devices can be used as a normal router and can be used as a SD-WAN as well. To just use the SD-WAN, you have to upgrade the image. Means the iOS need to be upgraded. Then it is going to be used. Is it clear, Muthu?
yes, sir.
Okay. So there are different devices which can be used and you can just upgrade them. So here what we are using, just this is CSR devices. So we'll see how it is going to configure under the SD-WAN. And these are the all Viptela S devices, but these are the virtual devices. All right. So now I'm going to just configure the PC. You can see this is a PC. This PC password is 123. You guys can note it down and just put 123. After putting this PC is going to be open.
Sir, I have one more thing, sir. You said something about, in your video, you said something about the traceroute and ping video in YouTube. I tried searching for that video. I didn't get it, sir.
Okay. So you want to understand about traceroute and ping?
Yes.
Okay, I'll explain. No worry. So if you want to just make the good look, so you just go there. Just good screen resolutions. So it is going to be nice look and feel. Click OK. So the first thing I have to go and assign the PC on the first Ethernet. This is going to get automatic IP address. So let me go here CMD and I want to check that what is the IP address. So one Ethernet must be have IP address, another have some PIPA IP address. So let me just check. So see, one interface already have the IP address, and this one have the 169, not a valid IP address. So I'll go in the Ethernet, and I'll go in the property and change adapter setting. So this one have the already IP address, you can see. So if you want to check the IP address, just click on the status and detailed. You are going to see the valid IP address. So this is for the internet, okay? This is the unidentified. So I have to go on this particular interface, and I just have to go in the properties. And after going in the property, I have to assign the IP address. So let me go there. And here I have the IP address. I'll give that 192.168.10.10. And this is my subnet mask. There is no gateway required because they are going to stay in the same broadcast. But if you want to give the gateway, just give the .1, which is going to configure on this vManage port. So I'll give the 192.168.10.1. That's all. So this side IP address configuration has been done. It is trying to identify, but there is no network configured. Another side of the vManage. So, but you can see this is the .10 is configured. Now it's time to configure the vManage because this is the first step we have to take the GUI access of the vManage. So we just have to open the vManage. There is no configuration. This is the entire blank lab. Okay. So I want to do from the scratch. So see, I just open it here. It is asking for the username and password. So default username for the any of the VH devices or CS devices or vManage, vSmart, username is admin, password is also admin. By default, it is going to be admin and admin. After login, you can change the password, but I'm not going to change the password. I'll again put the admin and admin only. All right. So what I'll do that, I will go here and put the admin, and again I'll put the admin. So it is asking you must set an initial admin password. So I will set again admin, and I'll reconfirm the admin. So it is asking the like available storage of the device. So we have the one storage. Just think about the one is the VBD and one is the VDC. So VBD have the higher storage, that is 100 GB, and VDC have the lower storage 3 GB. So you always have to select the VDB, right? Because you require the 100 GB storage to just processing entire thing for the vManage. If you're going to select the 3 GB, it is not going to work. So you always go and select the one. One is the 100 GB. So this is going to ask you would like to format that VDB. So yes, I want to do that. So put yes and just click OK. You all have to do the same steps. So it is going to take a little bit time, and then it is going to just format that entire thing.
Vishal, I hope we are recording this. I think just a reminder if we have not started it.
Oh, no worry, I forgot to record, I believe.
Yes,
No worry,
then
no worry. This video is going to be available. No worry. Thanks for reminding. Okay.
yeah.
I forgot to record in Zoom, but it is recording. Okay, so we have this vManage, right? And you don't have to put the password because it is going to take a little bit time until you are going to get a prompt. System is ready. If you are going to put the password here, it is going to throw an error. The system is in installations. You can see. So authentication failure. So if you're going to put too many authentication, this is might be going to be logged, or might be it is not going to work. So you wait until your system is going to be ready to use. So you're going to get a prompt automatically here. Now your system is ready. So just wait for a while. So see now showing system is ready. Now if you're going to put the password, it is going to see it is going to take your password. See, so this is the password. So just wait. Yeah. So now this device is fully ready. So if I want to see what is the default configuration available in this vManage. So if I want to validate, you just run the command show run from the CLI, and it is going to show the show running configuration. And you can see that we have some default configuration, and this is my default configuration, entire thing. So let me just little bit show you what is all available in the default configuration. So we have the three sections. One is the system configuration. System config, right? This is my like user name and user group, right? If you want to get this is my logging, right? And this is VPN 0 and this is VPN 512. So we'll discuss what is system-wise configuration. This is just for the login, like if you want to give the delegation for the like role-based access, like who should be read-only access, who should have the read-write access, which section he can perform, he cannot perform, net admin super user, like you can see. So we can see later on how it is going to be created from the GUI. This is the very important system-wise configuration. Let me just mark it circle. System-wise configuration is very important. So we just have to understand why this is very important. We have this VPN 0 configuration important and VPN 512 configuration important. And we also have to understand what is the service VPN. So service VPN we'll understand later on, but let's more focus on the VPN 0 and VPN 512. So as I mentioned that the first task to get the GUI access means I want to do the management of this particular vManage. So to perform this management activity, I have to configure my management VPN. And to configure this management VPN, what do I have to do that? I have to configure this interface. And under this interface, I have to assign the IP address 192.168.10.1/24. Right? So let me try to do that. Am I able to do or not? So if I go here and I'll try to configure the interface. So if I go and try to configure the interface ETH01. So see, this command is not ETH1, I believe. Not this command is not working. So one thing you have to note, if you want to do any interface configuration, you cannot do direct interface configuration on the any VAs, vManage, and CH you can do that, but VH, vManage, vSmart, vBond, you cannot do that, right? So you always have to go under VPN, and under VPN you have to do this interface configuration, right? Under VPN you can do interface related configuration, right? So here basically I have to do the my configuration for the management. So you guys tell me which VPN is relevant for me for this configuration. VPN 0 or something else?
VPN 512.
Yes. So thanks, Chidresh. So we have to go in the VPN 512 and then we have to do interface config, right? Whatever the interface I want to do that. Directly it is not possible. So let me do that. So simply I'm already in configuration. So I have to go VPN 512 and then I will go on the interface and my interface ID is exactly, you have to put the same interface ID, that is the ETH1, and then you just go and define the IP address 192.168.10.1. You don't have to give the subnet mask, you just have to put slash notation, not the entire subnet mask it is going to take. So this is the format it is going to take. Then you just put the no shut, and if you want to check the configuration, what configuration I have done, so you just run this command, see here. So under the VPN, you just go, means we gone in the interface ETH1 and we just did the configuration for the 192.168.10.1/24. Most important thing, any configuration you are doing on the VH and CH, by default, it is not going to apply in the running configuration unless or until you're going to do the commit. So you have to do the commit. So I have to do commit, then this configuration is done. So if I go and run the show run, you see this configuration has been done. So now if I go and try to ping from my PC, whether I'm able to ping this PC or means this vManage or not. So let me go here and try to ping 192.168.10.1. So the first packet drop. should be reachable. 192.168.10.1. Let me check. 192.168.10.10. I believe there is a cabling issue. Some virtual cable not working correctly. Else. So self IP is reachable. And now it's pingable. Okay, see? So probably it was taking a little bit of time. But if I'm trying to ping now, we manage it is pingable. Earlier it was not pingable, but now it is pingable. So all good. So we have the connectivity from this PC to this particular vManage. Now I have to take the GUI access. So once I have the basic ICMP reachability, then I will go on the browser. And after going in the browser, I will basically do the HTTPS and then 192.168.10.1. And once you are going to put, it is going to be reachable. Let me see one thing. So there is a command request.
I think SSH has to be enabled.
No.
I think.
SSH not required. There is one service. Let me check. NMS, all the status. So NMS application server, it's running, right? So this application server must be running. So it is running, so should be login. Means HTTPS should be there. Let me check it again. Sometimes it take a little bit longer time. Okay. Else we have to restart this vManage services again. Let me try with another browser. When you start this vManage, it is going to take 10 to 15 minutes by default to just run the services, right? So probably we just now done all the configuration. So it is going to take a little bit time. So we just have to wait. It is not going to immediately. When you start the vManage, it by default, it is going to take to 10 to 15 minutes because daemon is going to be sync and everything is going to be okay. Then it is going to work for you. So meanwhile, it is getting ready. We'll try to, let me try with another browser and we'll try to do the remaining configuration. Then we'll check. HTTPS. Okay. So if you have any doubt, like it's not working perfectly, so what you can do that? So you can do this NMS restart. So it is going to take some time and then your services is going to restart again, right? Every services is going to restart and then you can able to log in. Sometimes this issue happens, but this time it's not the issue, right? It's just like we started recently, so it is going to getting a like longer time. But in case sometime your NMS application showing in the waiting stage, right? It's not running, it's a running state. So for me, it's perfectly fine. It's just a matter of time. But in case it is not working perfectly, so you just do that request NMS all and restart. So all services is going to be restart. So it is going to work perfectly again after 10 minutes or might be 8 to 10 minutes. So meanwhile, this NMS is getting a start. What else we can do that? So let's complete the start. Okay. So you guys can see that how this restart is going to be happen. Any error is happening or not. Just wait for a few minutes. So now you can see the restart has been done. But if you want to check the status, so you just run this command. Now you can see every services status showing in waiting. So if it is in waiting stage, right? NMS application server. So this is similar to the HTTPS services. If you're in waiting stage, you're never going to be do the like this HTTPS browsing. So see my ping is working. There's no issue with the ping, but you can see my status is in waiting stage. So we just have to wait. Okay, so meanwhile, it is going to be in running stage. we do something else. What else, right? So we have this DC switch, right? And we have this vBond, vManage, vSmart and the roots here. So another prerequisite we have, if I want to bring them like in one fabric, first thing, they must have the underlay connectivity. Means they have to be like reachable. They all have to be reachable to each other. If they are not able to reach, they cannot join the fabric. So this reachability could be my local reachability, or if they are located in distributed like design. If you have distributed design means somewhere in your data center, the vManage, somewhere in the vBond, that is not recommended. So you can also do the underlay connectivity and then they can join the fabric. That is also option available. So in our case, what is going to be happen? We are going to just configure these all in the same like WAN segment, which having the same range of the public IP address, and they are going to connect with the same data center switch. And for the data center switch have the actual WAN link terminations. One is the internet link, one is the MPLS link. At the same time, also we are going to integrate our root CL, which is going to be connect with this DC switch, right? So how it is going to be happen? So in this scenario, you guys see basically what I'm going to do that I will create one of the VLAN, that is a VLAN 123 non DC switch, and this VLAN having 123.10.10.1 IP address, and these all port are going to be access port. Means they all are going to be in the same VLAN, and this 123 VLAN is going to pass on these all 4 ports. And here under this interface, we are going to configure this IP address. Under this interface, we are going to configure this IP address. Under this, we are going to configure this, and this one is this. Now, because they all are facing toward the WAN, so they are going to act as a transport VPN. So if I want to do the configuration of these interfaces, I have to go and do the configuration of the VPN 0, right? And then I have to define the IP address. I'll show the lab guide also how it is going to look like in the lab guide, the step-by-step configuration. But meanwhile, let me show you. So let me go on the DC switch first. And also I will use the vBond, vSmart, and the roots here. So this is my, I'll just do the host name, right? And this is my roots here. So I will just make no vSmart. Again, you have the username admin, password admin, right? And you have to change the password. So I'll put again admin and admin. So this is done. vBond also you have to do the same thing. Admin, admin. Now one important thing you have to note it down. There is no image for the vBond. There is no image for the vBond. Your VS device means VS device will work as a vBond. So we have to do one single line of special configuration on the VS devices, then it is going to convert it in the vBond. So basically VH itself is going to act as a vBond. You don't have to like deploy the special image for the vBond, either in the real environment or either in the lab. Actually, your VH is going to act as a vBond only. Just you have to do one special configuration, one line of special configuration, and then it is going to be converted in the vBond. So I will show what is that configuration. That's why you can see the image showing is the VH image here. It's not the vBond image, right? So this also you have to note it down. Now let me check what is the status for this NMS. So you see it is running, but still if I'll try to just log in, it is not going to log in. It will take a little bit time. So we'll try later on, 5 to 10 minutes later. Meanwhile, let me do the configuration. So I will go in the DC switch and I'll create the VLAN. So I'll create the VLAN 123 and I'll put the name, the controller VLAN, right? And then after what we'll do that, I will just create one of the SBI, and this VLAN 123 also going to act as SBI, and I'll define the IP address 123.10.10.1. So I will create one of the VLAN 123. I'll define the IP address 123.10.10.1 255 255.255.0, right? No shut. What next? I created the VLAN, I created the SBI. I will go and configure these all 4 ports on the same VLAN. So they will going to belong in the same broadcast domain. So what I'll do that, I will run the command interface range and the interface gig 0/0 to 0/3. So I will go gig 0/0 to 3 and I'll put the switch port mode access and then switch port access VLAN 123 and I'll run the command no shut and do right. That's all. So my controller VLAN has been created. Control plane switch interface has been part of this particular VLAN and you can see the configuration. So if I run the command show IP interface brief, so you will see the VLAN is going to be up after some time. It is down now, but it will going to come up. It will take a little bit time because we just see. So your VLAN is now come up because you just did the interface mapping. So unless or until your interface is going to be up, your VLAN is not going to be up. So now it's all good. Now let me do the configuration from the vManage side, vBond and the vSmart. So they are going to be make the underlay reachability. So I have to go my vManage, right? Meanwhile, this is getting ready. Let me try one more time. What is happening? So still not ready. Yeah, it's not ready. So we just have to wait. So I'll go in the vManage. I'll go in the configuration T. This time, basically, I have to configure my Ethernet 0 by Ethernet 0. So this is going to be part of the VPN 0 because it's facing toward the WAN. So I will go here and configure the VPN 0 and I will just put the interface and my interface ID is ETH 0. And I'll just define the IP address 123.10.10.10/24 and I'll put the no shut. Now, few things you have to remember while doing the WAN interface configuration, because these interface need to build the tunnel because these are the controller. So controller only going to build the 2 type tunnel. Either they're going to build a TLS tunnel, or so DTLS, or might be a TLS, right? There are no BFD, there are no IPsec, there is no OMP, right? So this vManage only going to build the control connection either from the VH, means this vManage to VH, vManage to vBond, vManage to vSmart. No other connection, no BFD, no IPsec, no MP. But still, whenever you are going to configure any interfaces, right, you have to define and you have to make sure your transport interface always with have the unique command line and they have this command tunnel interface. Means they are going to allow to build the tunnel, whether the TLS or DTLS tunnel. Same thing if I'm going to enable on the my VS devices, they also eligible for BFD and IPsec. So tunnel interface is going to enable your tunnel interface, means they are eligible to build a TLS DTLS connection. Also by default, few services are now allow on the WAN transport, not all services. Let me show you. Let me go on this vBond. And if I just run the command, show run VPN 0. So WAN interface, you can see we have the services allow for the DHCP only, DNS only, and ICMP only. But your SSSD, NetConf, NTP, other services are basically not allowed. HTTPS is allowed. But let's suppose you want to allow TFTP, you want to allow the Telnet or other services. It is not going to work. So if you want to allow all services, because we are in the lab, so we have to allow this all services for some scenario. Like I want to do some copy certificate from the TFTP server. So I need to allow the TFTP. So better I go and individually allow the services in lab environment. I can allow all services. So in case any services is required for my testing, it is going to work. So that's why I'm going to run the command allow services all. And that's it. I'll just make the commit. I'll show the lab guide also, what all written there. So two things I have done under the VPN 0 configuration means three things. I just go on the interface, assign the IP address, and also I make the tunnel interface and allow services all. By default, there are some services are not allowed and some are allowed, but I make the all allowed. Means they are just going to check allow services all. These all are not going to come in a picture. Okay. So this has been done. Now, if I go and ping my switch, see it is reachable. So that means this device have the reachability with this device. So this part has been completed. Now it's time to do the vBond configuration also. And I have to define the IP address G0/0. So they can connect to switch and also the vManage because they're going to form the broadcast domain here. So let me go vBond. I'll go here config T, VPN 0. Hers, you want to ask something?
No.
Interface, okay. G0/0. And again, I will give the IP address, this time 123.10.10.11/24. So see, this is the IP address. And I will make no shut allows, sorry, tunnel interface allows services all, right? And I'll just make the commit. So once I have done, let me ping my DC switch. It is working. Let me ping my vManage. It should also reachable. So now we have the underlay reachability from this vBond to my vManage as well. So this is also good. Now let me go on the vSmart. We're just building the underlay connectivity. Config T, VPN 0, and we have the interface. This interface Ethernet 0 this time, ATS 0. IP address, I will put 123.10.10.12/24. No shut, tunnel interface, allow services all, right? And I'll make the commit. So this is also done. And if I show the configuration, show on VPN 0, we have this configuration. So this has been done. Now let me just do the testing. So I will ping my DC switch first, reachable. I will ping my vManage, it is reachable, 10. I will ping my vBond, should be 11, and it is reachable. So now we have the complete controller base underlay reachability. Now let's configure the root CA. So root CA is normal Cisco router, which I'll configure as a root CA. So let me do the root CA configuration. So I will go here. And this is normal Cisco router. I'll put the host name as a root CA. And interface.
Vishal, just a question. Like in our lab, the vManage, vBond, and vSmart all are in same subnet, but it's not mandatory, right?
It's not mandatory, but in generally you are going to find in the same subnet because they are going to deploy in the cloud environment. So they are going to be in the same subnet only. But as I mentioned that the only condition they have the underlay reachability, they can talk
Yes.
to each other and then they will form the control connections. This is the prerequisite. Let's suppose I put this vBond in somewhere here, right? This side. But still, this vBond must be reachable to the vSmart and the vManage via this WAN transport. Then they are going to authenticate, they're going to validate. So it's not mandatory, all are going to be at the same site. But mandatory, they have the underlay reachability. What I'm able to ping right now.
Yeah, because I heard like vBond is usually with Cisco, and we authenticate our devices with Cisco, and then something like this.
Yes. You're right. You're right. That's what I'm saying. Like JTP process, always a Cisco portal. It's not a device, right? And this is a cloud base, and they are using the public IP address. vManages might be, and vSmart you're going to host in the Azure, right?
Yeah.
So these are the two different infrastructure, but how they are going to authenticate? So you have to do routing in such way. your Azure should able to reach to the Cisco and Cisco able to reach to the Azure with the optimal latency. All right. Then they can do the validation process. Clear, Manjit? So you are right. Means
Yeah.
whatever you heard, that is a correct, 100% correct.
Okay.
Okay, so let me see.
Vishal, do we not need any default route on the VPN 0 or VPN 512?
We'll configure, Chitris. We'll configure.
Okay.
That is going to be required. But
Yeah.
for naming, it is not going to be required. But it is definitely required for the reverse routing. Okay. Else it is
Okay.
not going to work for the remote branch location. So I'll
Yeah,
configure.
yeah.
Yeah. That definitely required. DC also required a default route. So I'll go on the internet and let me go and gig 0x0. I will just configure the interface. That is the 123.10.10.13. 123.10.10.13, 255, 255, 255.0. No shit. Go right. So that's all single line command. Now let me just try to make the reachability. So let me see. This is reachable. 1 is also reachable. 10 is also reachable. 12 is also reachable. Let me see. Yes, all are reachable. So now we have the under reachability. Let me see what is happening here. So now it is this vManage also reachable. It is trying to build the connectivity. Let me see if I able to lay out. Yeah. So we are good with the vManage also. So see. So whenever you just do the configuration, you start the vManage first time. You have to wait 10 to 15 minutes. Okay, patientfully. Then it is going to be ready. It is a default time. 10 minutes at least you have to wait. So now you can see I'm able to log in this particular vManage from this PC. And also we make the under reachability. So now let me just log in. So you have to put the username and password admin. So now you can see that. So we are on the dashboard of the vManage. This vManage doesn't have any vSmart, doesn't have any Vantage, and vWant. We have the vManage only. But still, this vManage is not valid. It's a invalid. You can see why it's invalid, because certificate is not valid. So if I want to make them valid, we have to do the certifications. So who is going to issue the certificate? In our case, we have to use the enterprise root CA, who is responsible to give the certificate, and based on that certificate, we can do the all validation process. Means it will issue the certificate. This certificate is going to install in the device. Further, this device is going to use some their internal database or credentials, and then it will ask to check my all detail and give me the final certificate. And once he will issue the final certificate, then it is going to install in this device, and then it is going to talk to another devices which having the similar kind of properties. So to do that, first we have to build the root CA. So we have to do the configuration for the root CA. So let me see if I can open the, let me, so if I go and check my, let me open. How can we build the root CA? So see, this is the configuration. So you don't have to use a lot of brain here. Why this is there? Even you want to build your server and you want to use as a server as a root CA, that is also doable, right? And there's a lot of way. Even this device, if you want to make as a root CA, vManage itself, it is also doable. A lot of way to make the root CA. So one of the like way I selected, that is to make this router the root CA, which is looks like more convenient to me. So I'm just using this root CA, and by referring this root CA, I'm going to issue the different certificate and which is going to install in the devices. So to make this root CA, you just have to do the configuration where you have to define the root CA name, host name, and also you have to generate the RSA key, that is a PKI, that is your, certificate name with this modulus 2048. And if you want to make this root CA as HTTP server, sometime required. In our case, it is not required. So you can ignore if you want. Then you have to configure this crypto PKI server. This is the PKI is the name of the root CA server. Then you have to install the certificate. Means once you have the certificate from this root CA, where you want to install. So I'm using here the NVRAM. Other boot flash also I can use, but here I'm going to install in the NVRAM and database level complete, and then issuer name. What is the organization who is issuing the certificate? So we are using that root CA dot lab. So this lab would be your organization name. It could be the unique name, and all devices should have the same organization name. That's also very important thing, right? So instead of lab, you are going to use some other name. It should be the same name throughout the all organization name configuration of the SD-WAN fabric. And this is the hashing method, and this is the password username, and then certificate is going to be granted, and this is going to be installed in the NVRAM. And you have to make this root CA as a TFTP server, so other devices can copy the certificate from these devices. Simple, right? So I'll simply copy this all configuration from here, and I will go on the router root CA, and I'll go in the configuration here, and I'll just paste it. So this is trying to generate the certificate, and you can see some SSH is enabled, and this is just trying to certificate server is enabled, right? One more thing, once you've done this configuration, and after that you just have to run this. You can just export this certificate either the flash system or the NVRAM. So I'm just going to install in the NVRAM only. Right? There's a lot of directory. You can use any of the directory to install certificate, but I'm installing the NVRAM. Just put the enter. So your destination writing file is the pki.c. This is your file, right? And final, you have to make this is the TFTP server where a file is going to be installed. And remotely, you have to copy this file. Most important, do write. Don't forget to write the configuration, else it is going to lose all the configuration and you have to do again. And entire certification you have to do again for the all devices. So always do write, because this is the device who is going to give the unique certificate for the all devices. All right, so what next? Once we done this, then what next? So the next is I have to check what is the certificate I have, right? So if I want to check, how can I check that? You just go and put in dir. You just put the dir question mark, and you can see a lot of directory you have. So I put my certificate not in flash, not in system. I put in the NVRAM. So just put in the NVRAM here. And if you do enter, you can see there is the certificate we copied, that is pki.ca. So if you want to see what is inside of the certificate, so you just run command more, and you just copy this command. Sorry, more. You have to give the directory name NVRAM, and then you have to put the certificate NVRAM. Then you have to put the certificate name pki.ca. So it is going to open a file from the NVRAM. So this is your certificate. This certificate needs to be installed in devices, and after installing this certificate into devices, they will use their local properties and they will request for the certificate signing request. And once they will request for certificate signing request, we have to granted the certificate from the root CA, and then we install in the vManage devices. This is all the step we have to do that. So do you guys want to do it right now, because it's going to take a little bit longer time, or you want to continue in the next class? Tell me.
Next class is better.
Next
Next
class will
class,
be
okay.
better.
Yeah. So that is going to be give the recap also. So
Yes,
I
and
can, yeah, please.
yeah, and we don't have the GUI access as well. So by the time that probably by the next we can have the lab access as well with us.
Yeah, definitely. Tomorrow you all are going to get the lab access. No need to worry. Okay.
Okay. Yeah. Thank you.
Yeah. So
Are we capturing this in a any kind of workbook or the files that where we can cut copy paste the basic configuration, or, or that configuration will always will already be there in the lab portal?
I person, if you guys want, I can just share the running configuration in the notepad. There is no
Yeah.
problem. I have to copy and paste, right? But
Yeah.
there are basic things, right? I'm assuming everyone is expert in the routing switching. Okay.
Yes.
So you can just do the VLAN level configuration, underlay configuration, static route, 2, 3 routes you have to configure. So it's just simple job. Yes, we like certification part. We have the lab guide.
Yes. This is
Yeah.
what I was
This
talking. The
this lab guide is
certification
available.
part.
Yeah, this lab guide is available. Let's suppose you want to build this. You want to configure this vManage. So what is the step-by-step process? This is all available, but simple thing not captured. So you can see what you configure system-wise, how the static default route is going to require. This configuration we have done, right? So
Yes. Yes.
how the certificate is going to copy paste, right? Which I am going to show you how do you download the certificate, and then what next step, how you can do the GUI, how you can further do the certification part, and then you have to generate the final certificate. Again, you have to generate the CSR. So that all available, right? And
Okay.
this is going to be helpful. So every
Yeah. This part was I was concerned about, that the how we create a root C and the other parts.
it's available, hers. No need to worry.
Okay. Thank you.
Okay, so let's conclude it here. Meet you in the next class and we'll do from here. All right?
I have one query.
Yes, please, Bhavana.
Yeah, so this root CA will generate the certificates, and these certificates will install to the other controllers. It is like that.
So whatever we have the one certificate, right? This
Mm-hmm.
certificate. Let me show you again. Let me open. This is the certificate, right?
Mm-hmm.
So this is the one certificate. Based on this certificate, we need to install this certificate on each and every devices, right? Like
Mm-hmm.
vManage will install this, vSmart will install this, and vBond will install it, and all VH will install it, and also CH will install it. After installing this certificate, they will use their internal detail, right? That is known as a certificate signing request. So like you can just think about their hashing algorithm, local information, like whatever they have the symmetric asymmetric key available with that devices. And based on that, they will generate the certificate signing request. So one set of certificate is there. Device itself use their own detail. Both are going to be combined and they will generate the certificate signing request. All right. Based on
Okay.
this certificate signing request, we'll come to again root CA, and this root CA will grant the final certificate. And this final certificate again going to install in all devices. So for each
Oh,
every devices, they will individual final certificate based on their device or might be their unique properties.
क्या करते
oh,
हैं CSR की
Okay,
कौन
Bhavana?
गया है कोई बंदा यहाँ का थोड़ी है
You clear, Bhavana? So we'll see how it is
yes.
going to happen. So that's why you can see in this vManage, you can see it. So we have the multiple steps. So in the first step, we generate the certificate, right? Now we have to copy the certificate from the root CA. This is the first step, right? We have
Okay.
done this step here. Let me show you again. This step we done, right? So this certificate will copy to the vManage via the CLI. You can see this is the command.
Mm-hmm.
tftp manage.
Okay.
This is the Linux command. Once we copy the certificate, we have to install in the home directory. Once we install, we have to do some settings in certificate in the GUI. Then what is going to be
Mm-hmm.
happen? Certificate will used, and then what is going to be happen? We have to go in the root CA, and after going to root CA, we just have to means we have to copy the certificate from root CA, the same certificate which I'm showing here. After that, what we have to do that we have to generate the CSR. You can see CSR is generated.
Mm-hmm.
And then we have to get this CSR and grant the final certificate. So final certificate, see, this is the granted certificate, final certificate is going to be there. And this
Oh,
certificate again, you have to install in the vManage, similar to other devices. then these devices is going to be finally up and working.
Okay.
So there are multiple steps we have to do that onboarding process. That's why I'm saying next class we'll see how it is going to happen. Okay.
Okay.
Yeah,
Thank
yeah,
you.
yeah. You're welcome. Okay, guys. So